Hey everybody, in this lab video we're going to be comparing the mass of an object to its acceleration. And the object that we're going to start with is just one of these green carts. We're going to pretend like there's no friction at all in this lab because we have a special track that we can put our cart on, and the cart is very special in that it has virtually no friction involved. We're going to have a string, as you can see here, that's attached to one end of our cart. And at the other end of the string, we will have a little weight, this guy right here. And we're going to hang this little weight over the edge of the table over a pulley. You can see over here I have the weight that's going to be attached to our string to the other end of the cart. And I'm just going to place that over the pulley at the end of the table. Because there's virtually no friction, any amount of weight is going to cause our green cart down there to speed up and come towards me faster and faster and faster. And that green cart has a certain amount of mass. What we're looking at is what's the relationship between the mass of our cart and how quickly it accelerates. The force that's being provided is just based on the force of gravity pulling down on this weight over the edge of the table. So let's take a look and see what happens. Okay, makes it speed up, not super duper fast though. For each trial of our experiment, we're going to add more mass to our cart. So right now it has a certain amount of mass. I don't know exactly how much it is. We're going to measure it on a scale. And so we're going to let the weight over the end of the table fall down. The cart's going to speed up, and we're going to calculate what its acceleration is. So we'll know the mass of the cart, we'll know its acceleration. Then, next trial, we're going to take one of these blocks and attach it to the top of our cart, like so. There it is. And then we do the experiment again. There it goes again. It's being accelerated from rest once again, but not as quickly. Let's take a look at our setup. So we have the dynamics track, we call it. That's this thing. And we've got a pulley attached to the end. We've got our cart, our green cart here. And these are just some screws in there to put and slide the mass over it. So see, here's the extra mass we're going to put on top. First we'll put just one on top. Then we'll have two of them on top of there. Then we'll have three, and then all four of them. Keep making our cart more and more massive. That's all those screws are for. Here are the four blocks. These are four metal blocks. We'll have to measure their mass so we know how much we're adding. I've got a paper clip and then a string that's attached to the cart, and that's going to hang over the pulley. And then the weight here, this is just a little, say 20-gram weight. You probably not see that very well. We're going to hang over the edge of the table. That's just attached to this paper clip over here. Hangs over the edge, and it makes our cart speed up. We also got a stopwatch because we want to be able to figure out what the acceleration of the cart is as it speeds up along the track. So we're going to need to know how long that takes, how long it spends speeding up. And we also have a ruler right here on our track, which we will use to know the distance that our car is traveling as it speeds up. Like I mentioned, you can see in the lab instructions in our class notebook. Let's let the camera focus. You can see the equation we're using to get our acceleration. It's a special equation from motion where we can find the acceleration if we have 2 multiplied by the distance the object travels, 2 times the distance divided by the time it takes to travel that distance. Wow, this autofocus is awful. Squared. We got to square the time. 2 times the distance divided by the time squared. I've already helped you out and showed you a distance that we'll look at. I've used the ruler on the track. There's a ruler right here. This is the 30 centimeter mark. This is the 100 centimeter mark. So that means our distance in between is going to be equal to 70 centimeters. But we're going to convert it into meters. So to go from 100 centimeters to meters, I just need to divide by 100. So this is going to be 0.70 meters. So there's my distance that I'll use every time I'm calculating the acceleration for each of our trials. Our time we're going to have to record for each trial because I'm going to have a different mass. So our distance will stay the same. Do 2 times the distance of 0.7 meters divided by the time it takes for our cart to travel between these 2 lines, or to travel this distance. We should get a time that corresponds with our first mass, just the 0.5 kilograms of the cart. Then we should get a different time once we do the trial again, but have another mass attached to the top. We'll again look at the time it takes to go between the 2 lines. That'll be a new time. And we'll calculate a new acceleration that corresponds with this greater mass. Okay, I'm lined up with the line, which is the starting position, 100 centimeters. It doesn't look like it's lined up because the camera has a different perspective, but it is lined up. I'll release it in just a moment. We'll have a clock on the screen for you to figure out the time that elapses between the starting and ending position. So you have an ending time and an initial time. Find the difference, and that'll be the time it takes to travel this 0.7 meters. So here's the first trial with just the mass of the cart, just 0.5 kilograms. All right, now we've added a mass, so this is our second trial, and we have a total of 1 kilogram. All right, here's our third trial. We now have 2 additional masses, so now the total mass should be 1.5 kilograms. All right, here's our fourth trial. We've now added, I'll show you, 3 in total, 3 additional blocks. So that's 0.5, 1, 1.5, 2.0 kilograms is now what we're accelerating. And here's our final trial with 2.5 kilograms. Make sure you go back and look at the lab instructions in the student notebook in our lab section. Make sure that we have in our lab report, you're going to make sure you have a labeled diagram, a procedure of listed steps, marker all over me. You also want to make sure in your analysis section, that you should have a data table where you show all the information that we found. So we had a distance the car traveled. We showed what that was. That was 0.7 meters. And then we also had a bunch of stuff to record in our data table. So you should have something like maybe trial number. And we did 5. Right, we did 5 different masses. 1, 2, 3, 4, 5. And then we had a certain amount of mass in kilograms. We said that was 0.5, 1, 1.5, 2, 2.5. Because we had a different amount of mass, focus camera, a different amount of mass for each trial. You also should have recorded times in seconds using that stopwatch on the screen. So you should have a certain amount of time it took for the object to speed up and travel across the 0.7 meter distance. So you should have numbers in here where I'm drawing these lines. And so this time is going to correspond to that mass. This time is going to correspond to the next larger mass. And you should also go in here and then calculate the acceleration, which we showed how to do. That would be in meters per second squared. How quickly is this thing speeding up? So we should have an acceleration that goes with each of these corresponding values. So on all my dashes here, you should have times that you recorded and accelerations that you calculated. As you can see in the lab guide, and as I mentioned already in the video, the way we are going to be able to calculate our acceleration, we say acceleration is going to be two times the distance, which is the same each time, divided by the time you recorded squared. And the time is going to be different each time. It should be a different time for each one of those values. And so you can get the corresponding acceleration for each of these different masses that we tested. Look in the analysis section in the lab instructions. We should also be creating a graph of some sort where you put mass on one of the axes and acceleration on the other axis and see what kind of pattern that we see.